Okay, so we're doing the entry task for Monday, March 1st or Tuesday, March 2nd. So we have two balls. Ball A is 2 kilograms heading 9 meters per second toward a stationary, that's important, so I'm going to underline it. Ball B. After the collision, ball A moves away at negative 4.5 meters per second, and ball B moves at 4.5 meters per second. That's positive. What is the mass of the ball? So something a little different than what we've done the last time with the velocities. We're finding the mass, which the process is going to stay the same. We're just going to put X for the mass. So we're still going to do before and after. I'll draw my line. So we have ball A, and we know that the mass of ball A is 2 kilograms, and the velocity is 9 meters per second. It's positive, so therefore it's moving to the right. And ball B is stationary. So remember, the little parentheses mean stationary. But we don't know the mass. So it's going to be X kilograms. And since it's stationary, our velocity is going to be 0. So that is not a trick. In anything times 0 is still 0. So even if it's an X, it's still 0. Okay, so don't let that fool you. So let's go ahead and set up the after. So ball A and ball B. It says after the collision, ball A moves away at negative 4.5 meters per second. So ball A, its mass did not change. It's still 2 kilograms, but this time its velocity is negative 4.5 meters per second. That means it changed direction. So now it's going to the left because of the negative. So after the collision, it turned around and went the other way. We still don't know the mass of ball B, so it's still X kilograms. And we do know the velocity is a positive 4.5 meters per second. So we have both sides set up. We still know that momentum is conserved before and after the collision. That means we have to know the total momentum before, and that equals the total momentum after. So we have to do our mass times velocity. So we're going to do mass, 2 kilograms times 9 meters per second, plus our mass times velocity over here. Well, we've got X kilograms times 0. So right there, we already know this is going to be 0, so we don't have to really worry about it. And 2 times 9 is going to be 18 kilograms meters per second plus 0. That's just 18 kilograms meters per second. So I'm just going to move that down here so we can set it up. We've got our before momentum of 18 kilograms meters per second. So now we're going to do over here. Still mass times velocity. So 2 kilograms times negative 4.5 meters per second. And we're going to add that to X kilograms times 4.5 positive meters per second. So we multiply what we do know, and then we solve for X, just like we did before. Okay, so 2 times 4.5 negative equals negative 9. And I know that I can't do anything with this X over here, so I'm just going to put it down here, knowing that I'm ready to move on to the next step as soon as I write this down. So negative 9 kilograms meters per second plus X kilograms, that's our mass we're looking for, times 4.5 meters per second, which is our velocity. So now we're ready to solve for X. So we're in the same situation we've been in before. We have to look for like terms before we start solving for X. So we have meters per second, we have kilograms, and we have a kilograms meters per second on this side, and then we have a kilograms meters per second on this side. That means we can combine like terms. Since this is a negative 9, we can add negative 9 to it to get rid of it. Negative 9 kilograms meters per second. That gets rid of that and leaves us with just this remaining on this side. What we do to one side, we do the other. So we also have to add 9 kilograms meters per second to the other side. When I do 18 plus 9, I get 27 kilograms meters per second. I'm going to drop down my equal sign. I'm done with that. Now I just have this over here. X kilograms times 4.5 meters per second. So now I need X by itself. So we're going to get rid of the 4.5 by dividing it out. Since they're being multiplied, we do the opposite. So we're going to divide out 4.5 meters per second. That's going to get rid of the 4.5 meters per second on this side. We got to do it over on this side. That gets rid of just the meters per second, leaving us with kilograms. That's what we need. So now I'm going to do 27 divided by 4.5, and that gives us an answer of 6 kilograms. So the mass of ball B is 6 kilograms. We also know because it's a positive number, it's going to the right. So it's a 6 kilogram ball for B, a 2 kilogram ball for A. All right, let's try the next one. All right, at the goal line, a 90 kilogram, oh, there went my whole lead. Let's push that back in. There we go. A 90 kilogram fullback moves at 8 meters per second, notice it's positive, and collides with a 135 kilogram lineman with a speed of negative 4 meters per second. The two players collide and move together as one until the play is over. What's their velocity? So they're going to move together. That tells us it's an inelastic collision. So I would assume one player is going to kind of pick up the other and move it away as they tackle each other. Okay. So we're going to do our before and after the same way. So before the collision, oh boy, here's where I'm a terrible drawer. So here we get stick people. We have two linemen before the collision. So the fullback is moving 8 meters per second positive. So this one's going to be moving to the right. And we know the mass is 90 kilograms and the velocity is 8 meters per second. The lineman has a mass of 135 kilograms and a velocity of a negative 4 meters per second. That means they're moving to the left. So here they come towards each other. So now we want to know what happens after. So we'll get that set up. After the play, they stick together. So they're tackled. Okay, so this is going to be a really terrible stick. Whoa. Let's just say he picked him up and he's moving him a little bit. Oh man, it's so bad. Now, their mass is 1 because they're stuck together in this tackle they're doing until the play is over. So we add their masses. So we're going to do 135 kilograms plus 90 kilograms. It just sort of makes me laugh when I look at it. So I know that 135 plus 100 is 235, but I'm going to take 10 away from that and say 225 kilograms is my mass. So together they have a mass of 225 kilograms. So now we know that we want the velocity after, and that's x meters per second. Okay, so let's solve for the before, and then we'll add in the after. So remember, it's mass times velocity, so 90 kilograms times 8 meters per second, plus mass times velocity on the second player, 135 kilograms times negative 4 meters per second. So I have to do my calculations. 90 times 8 equals 720 kilograms meters per second, plus 135 times 4 negative equals negative 540 kilograms meters per second. So my next step is to add the two together. I already have my negative 40 in, so I'm just going to add 720 to that and get 180 kilograms meters per second. That's the before momentum. Now the after, remember, in a sticky collision or an inelastic collision, it's really easy. We've got our mass and we've got our velocity, which is x. We can't do anything with them. So if we do our mass times x meters per second, we're at a standstill. So we're just going to drop it down here and continue with the problem together. So now we have to get rid of let me get rid of that hand that's sitting there. We have to get rid of the 225 kilograms on this side by dividing it out to get x by itself. So 225 kilograms, that cancels. We're going to also do it to the other side. Holy moly. It's because I'm running out of space on the bottom, so my hand isn't supported. So let's rewrite that. Let's try that again. Divided by 225 kilograms. Kilograms cancel. So, holy cow, nothing's working here. Okay, so I'm going to do 180. Oops. And I'm going to divide that by 225. And that's going to give me 0. Oh, you guys can't see what I'm doing. 0.8. And I'm just going to put a 0 after it for significant digits. But that tells me that after, they're going just under a meters per second, just under 1 meter per second. So they're going 0.8 meters per second after the collision, which if you think about it, kind of makes sense. We actually have this 135 kilogram moving this way. So they're going positive after, right? So they're moving this way. So my drawing's kind of bad. I should have had my other guy lower. But anyways, you get the point. Because it's positive, they're moving to the right after. So look at this guy's smaller, 90 kilograms, but he's moving 8 meters per second. So he has a 720 momentum. This guy only has a negative 540. So the smaller guy, because he's moving faster, has more momentum. So when he moves this guy, it's going to be really slow because that's a giant lineman in comparison to how much he weighs. So when you do kilograms, if you actually look up 135 kilograms in pounds, you'll see it's quite big in comparison to the 90 kilograms. So they're not going to move very quickly after. That's why it's such a small number, but they are going to be moving to the right. Okay, and that is it.